let's see how this goes. I thought, this is very exciting stuff. I'm really glad to be using this book because I was very frustrated with real computer forensics. People came to me in real cases occasionally, and I tried to help them, and I noticed that the techniques I was using were extremely painful and cumbersome. Had to make images of whole hard drives and then run special tools hunting through 500 gigabytes of garbage to find good stuff. And I was thinking, this doesn't really make any sense for the simple little cases I had. And then somebody came to me with a Mac that had supposedly been stolen for only a period of hours, and they wanted to know what happened out in those hours. Now, I couldn't find any free tool that could image the Mac, so I just wrote a bash script to record all the files within a certain period and get the answer. And I didn't know it, but I was inventing what this guy is doing. That's the same thing with incident response people. They don't want to go for the old-fashioned forensics that takes a giant image, which you then spend a week analyzing. They just want some script that will get a simple thing like a log file, summarizing the important facts without creating a monstrous mess of data. And now they're trying to organize this. So the first issue here is scope. Scope means trying to discover how big the problem is. For if somebody complains they can't get their email, it could just be one station is broken, or it could be that the email server is down and nobody can get their email, and that's a much bigger problem. So you want to look at the original complaints and do some quick analyses to decide how big is the problem here and what would be an appropriate way to track it down. So the original alert that caused them to declare an incident was somebody telling you about something. So go back and look at the original alert that came from wherever it came from, like an antivirus product or an intrusion detection product, because the person who complained about it may not be technical enough to have reported all the facts that were in there. It might have had more information, like an MD5 hash or a name of the file or an IP address or something. And you also want to know the exact time and date, of course. So then after you do that, you want to look at other detection systems. There might be firewall logs or other logs somewhere on the network that would also have picked that up, and you'll want those too to give you more clues of what happened here. And remember, the people that reported it to you are not incident response investigators, and they probably don't know how to think like them, so they will not give you the facts you want. You want to get back to the original evidence. And so you decide what sources you want to analyze, and you choose them not just because you expect them to have information relevant to the incident, but because you can get data out of them quickly. Like I was saying before, if you want to take 500 gigabyte images of hard drives and start analyzing them, that's going to take a week. So that is not your move at this point, because you're trying to decide how big is the problem. For all you know, bad stuff is happening right now. The bad guy's in there stealing important stuff right now, and it's not okay to wait a week to catch them because I choose a stupid investigation technique that's going to take too long. You want to find something you can do fast. So if you have malware, you want to find something like files or registry keys that malware creates that you can easily find with a simple WMI query. You want to find things, you can look in the Windows prefetch file, it's launching processes, maybe it's launching processes with a characteristic name, so you can just look through that folder, and if it's in there, that means you're infected. If it's not in there, you figure they aren't infected and go on to the others. Yeah?
Please fetch folder in Windows similar to like a temporary drop zone, like a staging zone, or like not a staging zone, but
what it is, there's a whole bunch of things that are very similar in Windows called the MRU list is another one. Windows keeps track of what you do so it can remember what you've done most recently and set it up to run faster next time. So almost all the menus in Windows remember what you've been doing and put the items that you use more often in a more convenient place. And so that means they have to spy on you to do that. And that's what the prefetch folder is. The prefetch folder is the last 127 apps that were launched. And it uses it when your machine is not busy doing something else, it prefetches those apps and puts them in RAM, so they're all ready to go in case you use them again.
Sort of like a cache.
Yeah, it's a form of caching. Yeah.
So how that's like LRU cache? How often does that get emptied?
The prefetch folder, I believe, never gets emptied by Windows. It just gets replaced as new things go in. Yeah. All right. Yeah.
The artifact malware directly creates on systems such as files and registry keys. What about service host files also?
That would be fine too. Sure. Services that are running would be another thing. Yeah. Network artifacts, running processes. These are all things you can easily detect and tell if it's there or not without having to wander through gigabytes of some data you collected. Then another thing is to look for independent sources. If you look at nothing but the files on one machine, that's not as good as looking at other things like the files and a firewall log on another device. If you have completely independent devices that are detecting the same event, then it's much more likely that you've really got an event of interest and you're not getting just random things that you're misunderstanding. For example, there's always a lot of strange files and registry keys on machines, and a lot of them look fishy or in fact normal Windows products or normal commercial products that just look strange and have strange names. So anyway, another thing is if the attacker is trying to hide their traces, they might be able to find the registry keys and the log files on your desktop and remove them, but they probably won't also know how to remove the entries out of the firewall log and all the other devices. So looking in more places gives you more chance of detecting something if you've got an attacker that's smart enough to try to hide from you. And of course, that's the game. Also, there are routine processes going on, like backup processes, defragmentation and stuff, where files are getting moved around and deleted, and that will tend to erase evidence eventually. So again, if you look at multiple independent sources, it's less likely that some kind of automatic cleanup process has removed the evidence. So you do a quick review of the evidence you find, trying to decide if there is some disaster currently in progress, like the attacker is still doing bad things. So come up with some detection method with your indicators of compromise and test it on a few systems, because you want to make sure that it's effective and that it doesn't cause damage to the systems, because you don't know. Your technique might use up too much CPU, so the system becomes unavailable, or the systems might be poorly, especially home systems get this way, but I think servers do too, where they just get all messed up because people install things, crappy things, and remove them, so they're fragile and they crash, even when you run an app that ought to run. So, all these, this is something you get used to in the world of especially Windows, but I've seen it on Linux too, where there's like 10 commands to use, but 2 of them don't work, and you learn to just use other ones. Unless you really have the patience to flatten it and reinstall it from zero, you continue to use the system even though it's a little bit broken. All right, so here's things to choose. You want to do actions that will answer a question. You don't want to go off in irrelevant directions. You want to get your answer fast. You want to make sure that you are following the evidence. It is very common, especially for amateurs, to make one theory and jump on that theory and run in that direction without really a good reason to believe that theory. This happens to me a lot in capture the flag competitions. I have an idea and I pursue it until it gets really hard, and I don't have the sense to notice that my original idea was not the only way to go. And anyway, so that happens a lot. You put too much effort in a single theory. It would be better to stay objective and say, do I really have good enough evidence that this is the problem to justify doing a bunch of work in this direction, or should I start over and consider another possibility? Anyway, and if you do come across something that is a real disaster happening, then you may have to fix it right away, even before doing further analysis, like the attacker is currently doing something horrible, like destroying all our files that can't be replaced with CryptoLocker or something. Then forget all the details and stop that. And then we'll do the rest of the analysis later. This is the same thing cops have when they have exigent circumstances. Normally a cop can't go in your house without a search warrant, but if there is an emergency, like some kid has been kidnapped and they're dying, that's an exigent circumstance, and they are allowed to go places without a search warrant and do emergency activities under those conditions that you would not normally do. All right, so here's one of the scenarios. They have a large online retailer, sort of like Amazon.com, and the book makes great effort to comfort their viewers by saying they've mixed together like 3 or 4 incidents here, so even though it may sound like your company, it's not really one particular company they're talking about here. So you work in the security department, and your customers complain that after they shop at your site, they start getting spam. Now, the first thing is, that's a pretty vague, unclear complaint. Like, people get spam all the time, you never really know why. A lot of people just say, just ignore them. I mean, customers are full of stupid ideas constantly, but suppose you consider the possibility there might be some truth in it. Then there are ways you could go. Now, one thing you could do is work with the customers, try to read their email, try to figure out when it started and all that. Now, the problem is, you don't really have much control over the customers, and you can't really see the details, and they have their issues of privacy. So this is probably not a very productive way to spend your time. What's a whole lot wiser is to make new fake customer accounts that you control, and now you can monitor them, see when the email comes, and now you can play games with them. That's probably better. And that will also tell you if the incident is still going on or if it was something in the past. I know there was a big company like Amazon or something about 6 months ago. They said they'd been hacked. And it turned out that somebody else got hacked, and they got a large trove of email addresses, and some of those people also had Amazon accounts with the same password. So even though Amazon didn't, I don't know if it was Amazon, even though they didn't get hacked, there was the appearance that they'd been hacked for a while, and there were a few hundred people whose passwords had leaked out. So a lot of things could cause you to get spam that are really not the problem of this company. But if you make a fake account, and it's on your server, and it starts getting spam, then you have pretty clear evidence that we really have a problem here, where our emails are leaking out. Yeah.
I just heard from Bank of America that now their new policy is that if somebody reported something on their credit debit card, and you were at that shop, you're also getting a new card.
Oh, that's a good idea. And I know, say, when I found security problems at Wells Fargo, Chase Manhattan, and American Express a few years ago and demonstrated at DEF CON. I contacted them before that, and they promised me they'd get back to me in 48 hours, and none of them ever called me at all. They just couldn't care less. Anyway, yeah.
Isn't Amazon a type of company that also sell your information, like your email address?
Well, that's a good question. But of course, if the company does sell your email address, then they wouldn't be surprised you get spam. So the postulate here is that you did not intentionally sell their email address to spammers, and yet that's happening. It's a good point, though. A lot of people do. I don't know if Amazon does. I kind of doubt it, but a lot of people do. Anyway, so we make your fake accounts. Now, one thing that bad guys do is they generate random word lists, like mix together words and letters and send it at yahoo.com. You just try to hit it. So instead of just using ordinary names like Tom and Fred, use like 64-letter random names. So there's no way they would guess that by accident. And then the only way someone could possibly find that address is if they stole it from your servers in all practice. So that means monitor those accounts. If they start getting email, then it must have come from the evidence on our servers. So the preliminary evidence is while you're waiting for the spam to come in on those accounts, you might look at other things like where are the email addresses stored on our system. Apparently they're leaking out somehow, so let's find out how they're handled, how they pass through. So it turns out they're on one internal database and one external database. You have one big giant internal storage device with all the email addresses and other customer information, and you have some external marketing company or something that has those email addresses. So it could have come from here or it could have come from there. So then you interview people. The database is a commercial product with a gigantic hard drive, 500 gigabytes in size. It's an array. There's a ton of traffic in and out and a lot of updates. The updates can be made either through the web form or manually in the customer service department by directly typing them into the database. And that's it. You also have backups. So that's another issue. So it could be the offsite marketers. It could be somebody stealing the backups. Or it could be somebody is stealing the data from the website on the way to the database, or it could be someone is stealing it from the database that it goes into. Any of those could be ways it's leaking out. So they determine it's unlikely to be the marketing department because the offsite marketer only gets updates once a month. And some people got spam before a month had passed. So it didn't have time for their address to percolate to third party, so you can exclude that. The customers calling in by phone, it's very unlikely that they're intercepting the phone calls. That can be done, but that wouldn't get a mass record, and it's very rare. So you're going to have, now you cannot really examine the network traffic going to the database because there is so much regular traffic that it'd be very hard to find the bad traffic in there. So you might want to watch the queries on a database instead. So then there are various theories. One theory is you have an insider selling your data. That could happen. But there's no way to test it, really. I mean, that is everyone's nightmare. That's why the NSA is so nervous. What if you had another Snowden? How would you know? How would you get him? Nobody has an answer for this one. Everyone's scared to death. But since you can't proceed in that direction, you might as well proceed with other theories. Unless you have some kind of more evidence that there's an insider doing it, it would be hard to test. So then they try to test this one, go to the website and enter some fake data, and then enter some data directly without going through the website. Some fake accounts this way, some fake accounts that way, and wait to see which one of them are going to get spam. And also put fake accounts in the backups that were never really in the database at all. And then you'll know if someone's stealing your backup tapes. These are more tests to do. These are all versions of the barium meal, which is a very old spy technique. If you think there's a leak, you tell different lies to each of the people you suspect and see which lie goes out. So it's a standard technique to track down leaks. So when you finally get spam to your fake accounts, and you find that it also gets spam in the accounts manually entered into the database, that means you can quit worrying about the web server leaking. It's the database leaking. And there's no spam from the accounts on the backup tape, so it appears more clear by process of elimination that the problem must be on the database server. All right, so you can do packet captures. It would be very difficult because you have so much traffic, and if it's encrypted, you'd have to decrypt it all. That could really be a drag. What's a whole lot better is to just monitor the queries. The network traffic is going in and out, dumping all these stuff, but all you really care about is queries on a database because that's what actually reveals records, like email records. And as a matter of fact, you only care about queries that contain email addresses. So you could just get the log of queries and exclude most of the entries in the log too. And that's the right way to always think, is find some way to get a small data set that you can quickly search through instead of accumulating a monstrous pile of data that's another whole project to dig through. Yeah?
When you say decrypting packets, do you mean like stripping out TLS and SSL?
Hold on a sec, I gotta wait for them to quit making all that noise out there. Of course, somebody's burning down. I suppose they feel justified in doing that too. Yeah, what's up?
I'm saying, is it like when you say decrypting packets, you mean like stripping out TLS or SSL?
Yes. And that can be done, but it's painful And it's not really worth it because I don't really need the network packets. All I really need is the queries. So very often you find raw network packets, raw RAM, raw hard drive is a waste of time. All you really need is some kind of log that gives you the information that matters. I don't suppose we're on fire.
If they come and stop here,
It's getting awfully loud. I think whatever it is, it must be on campus.
It could be a medical emergency too, like something.
Could be.
Down the street, so.
They are, but that's not going on Phelan Avenue. That sounds like, well, anyway, they've gone away. We're not dead yet. So, all right. So, so the next step, make some more fake accounts, talk to people to find out where the data is stored, scan through logs to try to see what's normal, and look to see if there are normal queries that would get a lot of email addresses. And they find there are no normal queries in normal operation that would get many email addresses at a time. So 2 weeks later, the new accounts get spam. So now you know they are stealing email addresses in periods of 2 weeks. And that's going to be a big dump. So they look at the query logs from the time that the spam arrived, and now you can find a query which selects for all the new customers in a time period. So apparently they're stealing all the new accounts every 2 weeks with a query on the database server, and that's a clue how they're getting in there. So there's your query, you know what time it came in, you know what IP it came from, and it's a company IP in the graphics arts department, but it's using a database administrator's account. So that strongly suggests that it's an outside attacker doing this. And if you talk to the graphics art department, they should never be handling any of the data in the database anyway, or customer email addresses. They really have nothing to do with that. And so now you have leads. It does appear to be true that your customers were not making this up. There's a real problem. 2 week cycle of theft, and the database queries are made over the network from the graphics arts department. So now you have a pretty good idea. Somebody managed to sneak in the network, steal a username and password, overcome a machine, and use that machine to steal the data inside. So the graphics art desktops, now you want to take collect data from that, and you use the live response data, which is the fastest and most common thing. Then you might also want to make forensic images of the whole hard drive and memory on this machine, because you have strong reason to believe this machine is under hostile control, and it might be worth analyzing that stuff. And then you can interview the user and find out things like how long have they been using the system, did they see anything funny happen, is it left on all the time, and things like that. All right, and database server, you want a live response and all the logs. Remember, you cannot really do a hard disk dump of the database server because it's a huge network storage array. And also, there's no particular reason to expect anything good in there. That's all the data, the database, and that's not the problem, is bad entries in the database. So the logs are pretty much all you want here, and normal live response, which tells you just basic facts about the system, like registry keys and such. So the workstation, looking at the image, since you know what time to look for it, you can find malware on it, find that it's persistent, and restarting when the machine restarts. The malware has been installed for 2 years, which is very common. Somebody's had malware on it for a long time without ever knowing it, and therefore you cannot find the original entry point anymore. You don't have any logs that go back that far. Somebody 2 years ago got an email and clicked on a link or something, and you'll probably never find out what happened. This, by the way, bothers me because the remediation step where you say, how are you going to prevent this from happening again, is going to be kind of weak, but that's the way it is. And there's your final steps of the investigation. This is not talking about remediation anyway, but then use the host-based inspection tool to look at live response, things like file names, registry keys, and so on, to see if there's more of this malware around, and then look at your firewall logs to see if more things are sending it to that IP address, and hopefully removing the malware you find will stop this attack. It's not thoroughly satisfying because you haven't really recreated how the attacker got in, but it is just the normal order of business that people are going to get end workstations compromised occasionally, and I was thinking in the long run something like updating your network monitoring systems to detect suspicious things coming from database server might be a fix. But anyway, suppose you, the mistakes you could have made here. If you have complaints from customers, then you could assume that the data is somewhere else in the network, and you can start searching for other records about those customers on all the files everywhere, thinking there's got to be an unauthorized copy of the data somewhere in the network. Or look for large files, thinking somebody's making, somehow an extra copy is being made. The problem here is that you don't have any evidence that the stolen data lives on a company server for any period of time, and you don't have any evidence that it's all stolen at once in a large file. So if you start off with a wrong-headed idea like that, you'll spend a lot of effort with very little chance of finding anything important. Another unwise path, if you were convinced an insider was doing it, this could easily happen because you could have a top executive in the company that actually trusts their security tools. They paid a ton of money, and the security staff, of course, went to them and begged for, please buy this firewall, it'll solve all our problems. So they say, okay, it's solved all our problems. Therefore, since that solved the problems, it must be an insider doing it, because if they were actually malware or something, it would have got stopped. Now, this is the problem with overselling your security solutions. But anyway, that could happen, and then you could waste all your time trying to find out which employee is disloyal, doing background checks, surveillance, video surveillance, and all that jazz, and all this will just irritate your employees and lower their morale and not find the problem. So it's a shame to start on a wrong path like that actually hurts a lot of people. Anyway, that's a witch hunt, and it's not something you want to do unless, and it's not that this isn't always the wrong thing to do, but before you do that, you ought to have some real evidence that it was an insider doing it, not just assume that your security products are perfect and the insider is the only remaining solution. All right, another Unwise path, you could hunt through the database server. We're going to RAM in the database server. The hard drives are too massive, but you could dump all the RAM off the database server and then hunt for malware on the database server itself. But you don't need malware on a database server to steal records from a database server. The malware could be somewhere else because it can just be sending queries to the database server and getting the data without malware involved. So that's something they mentioned several times in this book. Many companies assume that every problem is malware because they understand that they have any virus, and that's something. If something bad happens, it must be infected. But that's not always true. All right, and so if you jump to a conclusion and go down the wrong path too vigorously, you waste a lot of time getting nowhere. All right, so another scenario here. An automated clearinghouse fraud. This happened to several companies in the last 6 months. Somebody just sent an email saying, please transfer $50 million to this account. Thanks a lot. They make it appear to come from the CEO or something. So somebody actually succeeded in doing this, and the bank caught it. Banks are getting very good at detecting suspicious transactions, going to funny countries, not meeting the normal pattern of expenditures on credit cards and everything else. So in this case, the bank detected that your company was sending a large amount of money to some fishy-looking account and they didn't pay it, which is good. So now you have not lost money yet, but you certainly want to find out what happened here and stop it from happening again. So they connect the CFO, that's where the account was from, but the CFO did not authorize it. So somebody managed to execute a transaction without proper authorization. And you want to find out how that happened. So it was initiated online using their bank account. You know the amount, you know the time of day, and you know the source IP address, which was your public IP address. So that's basic facts to get you started. So the first thing, the firewall is available with logs. That's easy. It's not hard to get, not hard to scan through, so you might as well look at the firewall logs quickly. You've got the CFO's laptop, which was used, so you could do live response, get the RAM and the hard drive. That's another option to go, but there might be other computers involved. So the firewall logs are obvious. Look at the time, see who logged in, and you find two computers logging in over HTTPS, making a lot of connections in the time period, around 4 p.m. from two different IPs. One is the CFO's, and the other is an IP that's not obvious what it is. So there's now two immediate tasks to go forward. The first thing is get more evidence from CFO's computer, because now you have direct evidence that that computer was really used to do something unauthorized, so there's probably some kind of malware on that machine. And the next thing is find out what's going on with that other IP address. Where is it, and what could it lead to? Therefore, you're going to need DHCP logs, which are going to lead you to the MAC address of that other machine. And when you do, it's the MAC of the CFO's laptop, so it had two IP addresses, which can happen it happens if you have things like virtual machines. All right, so you interview the CFO. The CFO left for the day at 4:30 and had some meeting, but he didn't use online banking and he didn't initiate the unauthorized transfer and he doesn't know the account. So you've got firewall logs showing a connection to the CFO's computer to the bank. The CFO denies doing it, and you have firewall logs for 2 weeks, and you have all kinds of information from the CFO's computer to analyze. So here's theories. Maybe somebody went into the CFO's office and used his computer. That would do it. Maybe there's malware on the computer, giving a remote attack. You can test these theories with the data available. One issue is that the office space is open, there's windows, so somebody probably couldn't realistically go into his office and mess with his computer without somebody seeing it, so that's not likely. So you look on his computer for malware and you find it. A persistent executable, this is a big issue. If you infect something, the first thing you always do is make it persistent. Otherwise, when you restart the machine, the attacker's process will stop and you lose control, so you put on a rootkit or a bootkit for different systems that every time it boots up, it will rerun the malware. And that makes it pretty easy to find because there's only a limited ways to make something start automatically, and there are plenty of tools that scan just all those auto-start extensibility points. So they find that he's infected with Zeus malware, which is a really popular one. used in crime kits, where you just pay for the kit, you click on buttons and have malware, put it on a website, send out spam, and criminals are doing it all the time. We had it here when we had the big virus scare. We found a couple people that had downloaded Zeus. It's very common. So now you really know that this laptop is the problem. It's worth doing a real thorough investigation there. So look for the various characteristics of malware, like registry keys and such. Look at your firewall logs to try to see what else is infected with the same IP address for the command and control server. And that's the way you can now move forward in a reasonable way to solve the problem. Here's things that could have gone wrong. If there's no alerts from your antivirus or IDS, because this was a modified Zeus, and all you have to do is modify binaries a little bit, and antivirus won't see them. So again, if you actually trusted those products and thought that means we don't have malware, then you could blame the bank and go call the bank and yell at them, you lost our money, somebody's infected over there. And this is, of course, wrong-headed and not getting you anywhere. But this is another thing an awful lot of management types like, because it makes it someone else's problem. Not my fault, somebody else did it, go yell at them. Right, that's the problem. You have to make sure that, in first place, you haven't validated what the bank said. I mean, if the bank tells you this happened, you should at least check your systems and see, did we in fact make that request from our systems? Because if we did, then we have a problem here. And you should check for that before you go yelling at someone else. Did we create the problem? And then, of course, you shouldn't trust any of your security measures all that well. And you shouldn't assume that you can get any help out of a third party. I mean, why would it be a priority to them, especially if they don't believe you? All right, so another unwise path. This guy believes that the security measures are strong, so he blames the CFO, and he wants you to investigate the CFO who must be betraying us. Again, this is something, in the absence of other evidence that the CFO is disloyal and a crook, this is a poor conclusion to jump to and investigate right away, because it's just going to irritate the CFO, and that's the point. And if, by the way, if you are a computer security expert, you are not qualified to do an investigation of a human being. That is an entirely different detective work, and you should outsource that to someone else that really specializes in that kind of work. Anyway, yeah.
Wait, given the CFO's laptop is going to be in live response,
Yeah.
they're also going to replace it with another device.
Yeah, or give me a different laptop.
And the device, if it occurs again, it's pretty odd.
That's right. If you give him a new device and it occurs again, then that might mean he's disloyal, or it might mean there's a problem somewhere else that's causing it. All right, so I'm down to the eye clickers. Come grab one if you need one. We'll do these and then we'll take a break. I think I'm all connected and everything. All right. Start new session. You have paper to record the answers on. Life is good. All right. There should be 3 letters, so there should be enough for everybody. All right, good. All right. Fair enough. All right. All right. Let's see if I can get this thing out of the way. All right. Coca-Cola has been hacked, and they're sure Pepsi did it. So what should you do? Guess I'll wait till 40. All right, and let's see, I think I have to go, oh good, all right. So in this case, you need alternative theories. You have jumped on blaming, you have one conclusion, and there's no reason to proceed until you consider alternate theories. I mean, that's, unless you have evidence that you know who attacked you, there's no point starting from the IP address of who you assume would attack you. You need to consider alternate theories before you do anything else. You're getting stuck on one path, in the absence of any evidence to really back that up. All right. Mint has been hacked. This happened to them. They found out that their downloads had been altered and people were downloading poison files with malware in them. So what should you do? This happened to Mint twice, about 3 months ago. It happened to them because the first thing they did was re-image the servers, and they just got hacked again the same way. They're a fine example of poor incident response. quit at 40. All right, this is one of those emergency situations where you should fix the problem immediately. You should stop more people from downloading poison. Just turn off all the downloads and put up a maintenance page, for example, or replace the downloaded files, although that's kind of weak because since you haven't kicked them out, they'll just poison them again. But you certainly shouldn't just let people keep downloading poison from your site while you investigate. Yeah.
What does continue along this path mean in this context?
In this context, I don't think there is a good way. Yeah, there's no good way to continue along the path in this case. Yeah.
Oh, okay.
Some of the others, there's a path suggested.
Oh, I
Yeah,
see.
yeah. All right. Yeah, these questions are written by an underpaid person. Yes, right. That's why they're extra credit. There are often little problems with the question. Anyway, so for example, now I don't think it's listening. Now it's listening. All right. So a database server's been hacked, and you see suspicious queries every day at midnight. The database administrator wants you to make a disk storage and network storage array and analyze that. What do you think of that? I'll quit at 40. All right. And the problem here is that is too hard to do. You should find other sources of evidence that are not so expensive. They don't require storing so many terabytes of junk and hunting through it, like just looking at the logs instead of imaging the whole hard drive. Yeah.
That was actually my initial answer, but I
Yeah.
think D is also like kind of
Alternate theories?
Yeah, because it's like, I mean, those two kind of go hand in hand because like alternate theories are how you
Well,
decide
here-
what evidence to collect.
That would
Well,
be
no,
the
here we
first
don't even
question
have,
like that,
here
too.
we don't even have a theory of how it happened. We just have the fact that we find queries being executed and they're suspicious. So that's why I prefer this one. But that's not bad. Yeah, I understand. That's why I make them extra credit. These things are mostly just to keep you awake. Anyway, occasionally people convince me to change the answer, but I think in that case the best answer is seeking other sources of evidence. Because it's not that you have great doubt about what you're trying to find, it's that you're going about it in a foolish way to find it. Yeah.
What would be a possible source of evidence?
Oh, logs would be the first step. Look at the query logs, and then like in another problem, you'd then look at like the network logs, firewall logs, and the web logs to see if perhaps something else is actually the problem and extending those queries.
Right.
But delving deeply into the RAM or hard drive images is just a waste of time. Logs will give you a clue a lot faster.
Well, wouldn't it, you would do that alternately as well as the logs?
No, because remember that's the point of incident response. Find something that is fast and efficient. And then don't bother digging in deep until you locate where the problem is. And then you dig in deep where the problem is. If you have to. You may never have to dig in deep to find and solve the problem. All right. Remember, you're built by the hour and you're trying not to waste a lot of time. Yeah. All right. So you got a hacked network and you find an IP that is being used to control the CEO's laptop. He demands that you hack them back and steal their files back from that machine. What do you want to do about that? That could easily be.
As you read this question.
There is a student working on a project of taking over a machine through the iClickers. As far as I know, he hasn't succeeded yet, but he might. Anyway. Anyway, Alan knows about it.
Osmosis.
We'll see if it happens. That would be pretty awesome. I said, great, let's see it. So, all right, so in this case, you should quit. Because they're demanding that you do something illegal.
Oh, what's going on?
That's right. But
I didn't click it. We didn't.
you didn't click? Well, I had it going. Anyway, some people click. Anyway, so the point here is they're trying to get you to commit a crime, and you don't help them commit a crime. You just quit. Don't work for people that demand you to do illegal things. Anyway.
Is this a new software program?
Yeah.
Okay.
Used it last
That's
week.
what I didn't
All
see it up
right.
there.
Well, sorry about that. I'm not trying to rip you off, but I have my general excuse, which is everything is extra credit. So this is 121, Chapter 6, I think. All right. So let's take a break.